Welcome back, everybody. Great to see you this afternoon. It's Tuesday. We got the Artemis II launching going on tomorrow from Florida. It's a big news, big day for the space enthusiasts. So as NASA prepares for the launch of Artemis II, it's easy to forget the liftoff is just one hurdle to overcome. Once the 4 astronauts are on their way, they've got about 10 days through space where they're going to be beyond the protection of the Earth's atmosphere and magnetic field. So we've got other issues to be concerned with, and namely solar flares. But what makes this space weather such a hazard? Here to break it down with me is Dr. Thomas Berger, the director of the Mauna Loa Solar Observatory. And Doctor, thank you so much for being here from Boulder, Colorado. I appreciate it. It's something special once this thing finally clears away from Earth. There are other things to consider, like space weather.
Absolutely, Bob. Thanks for having me.
Of course.
We're watching the sun closely. It's pretty active right now. We're coming down out of the peak of solar cycle 25, which means we have a lot of sunspots on the sun. Still, these are the sort of magnetic volcanoes, if you will, on the sun that are actually what erupt and cause solar flares. They also throw out radiation, and they throw out what we call coronal mass ejections, these large plasma explosions coming off the sun. They can drive radiation storms out into space, and if they come towards us and towards the astronauts in the Artemis II capsule, for instance, on their way to the moon, they can cause some radiation hazards to the astronauts. So what we want to do is watch the sun as the mission occurs, and as you see here on some of these images you're showing, the sun can have these kind of bright flaring explosions, and we will be watching closely throughout the mission. And we have an instrument on Mauna Loa, as you mentioned, that looks right down to the surface of the sun and can see these eruptions coming off immediately. And we'll be sending alerts to NASA immediately when we see these eruptions, these coronal mass ejections, so they can evaluate whether they think they're going to be a radiation danger to the crew.
Doctor, how long would it take for a coronal mass ejection to reach the capsule once you spot it?
The first thing that happens when you get one of these big eruptions is the photons come out, the flare. The first thing you see is the big flare. That has some X-rays in it that can be a little bit hazardous if you're outside a capsule. If you're in the capsule, the X-rays don't get you. What then comes are the energetic protons. The big radiation storm comes about 15 to 20 minutes perhaps after the eruption. And then the CME itself comes rumbling out later. That maybe takes a few hours at minimum, maybe even a day, to get all the way to the Earth. But we really worry about the radiation within about 15 to 20 minutes after we see the flare indicating the eruption on the sun.
Well, so I was going to say, Doctor, so let's say you've detected one, just for instance. Is there a shelter on board where the astronauts can head to?
Yeah, they do have. What they're going to do is they're going to gather around some of the luggage they have on board, if you will, create a shelter in the capsule itself, and the astronauts will shelter within that sort of dome of luggage that they create to try and give them some extra padding against these incoming protons, and that'll keep them somewhat safe against these protons as they come in.
Well, let's talk about the last couple of days. How has the sun fared? Has it been aiming stuff towards us? And what kind of weather are they running into right now?
It's looking a little active. We have an active region, as we call it, a bunch of sunspots that are looking kind of complicated, have been flaring. We had an X flare just yesterday out of this region. And so it is an active period. It's not maybe as active as it was a few months ago, but there is a risk that this particular sunspot region that's on the disk right now could create an eruption and send radiation in our direction.
Even a weaker one, would that disrupt any kind of communications between the capsule and Earth?
Potentially. A solar flare, these big X-rays that come off, the first thing you see, they do ionize our atmosphere a little bit more. They cause radio interference, but the frequencies they use to communicate with the capsule are such high frequency that they go through this kind of ionization problem. We could see some radio interference here on Earth, but not to the capsule.
Okay, good. That was the one question. And I'm trying to go back. I mean, I'm 53 years old. I don't remember the last time that they were up there, but we're talking 1972, Doctor. I don't remember them talking about solar radiation and flares when they're going towards the moon and back. Is this something they didn't even worry about in the 60s and early 70s?
We knew about it back then. In fact, they got very lucky with Apollo 16 and 17. Right between those two missions, there was a very large radiation storm which had the Apollo 17 astronauts been flying at the time, may very well have been sickened by that radiation storm.
Wow.
So Apollo did get lucky. We weren't paying as much attention, perhaps. We knew about it, but now we're really aware. And we have the NOAA Space Weather Prediction Center. We have the NASA Space Radiation Analysis Group really keeping an eye on things.
Yeah, so I'm assuming the technology has gotten better where we can detect them better from 1969 when Apollo 11 lifted off?
Definitely. We have space telescopes. We have the ground-based Mauna Loa Solar Observatory I mentioned that we operate, which can see right down to the surface, get these eruptions right as they come off the surface. The space telescope images you're showing now are very useful for seeing the flares and the eruptions. Where they occur on the disk is important because that tells us what direction that eruption might be going. So we have a lot more instrumentation up there. We have a lot more knowledge. We have models we run, but it's still a risk. They're
Yeah.
taking a risk.
It's fascinating to watch even these pictures right here. I know that it's time lapses, but Dr. Berger, are you nervous at all about the next couple of days with the sun's activity, or are you okay?
We're not seeing really huge sunspot activity that would give me pause for a really severe event, but you never know. The sun can evolve quickly, and we're keeping an eye on it for that reason.
Well, I appreciate you taking the time out. Great discussion, Dr. Thomas Berger. I appreciate it. It's great to talk to you, my friend, and next time we shoot one of these guys up, I'd like to talk to you again about it.
Absolutely, Bob. Thanks for having me.
Absolutely.